Welcome to Data Skeptic Time Series.
This is Data Skeptic Time Series, the podcast about how to predict the future based on historical sequential data. Episode number... OpenTelemetry is a set of tools that enable software developers to instrument their code in a common standard and have the flexibility to direct metrics, logs, and trace data into any system that can work with the standards the OpenTelemetry project has defined. Monitoring that time series of information that pours out of a distributed software system is a challenge only possible with a standard like this. And today I interviewed John Watson about the OpenTelemetry project.
My name is John Watson. I work for Splunk at the moment, but I also have a PhD in astrophysics from Northwestern University and have been working in the software industry since 1998.
So how did you get from astrophysics to where you are today?
So as a part of my dissertation work, there was a lot of software engineering, or at least software programming, I would say at that point. Software programming involved. I had to write code to analyze my data. I wrote some code to model what my data might be showing. And, I've been writing code since I was a little kid. And I kind of found about probably halfway through my dissertation work that what I really enjoyed was writing software. I mean, the astronomy was interesting, but what I was passionate about was the software. And so I had a fantastic thesis advisor at Northwestern, Dr. David Meyer, and he was very supportive of me kind of wrapping up the research that we had in progress, writing a paper, writing my dissertation, defending, and then moving on and going to do what I was really passionate about.
So I've used Splunk for over a decade now, I think, off and on, and it feels like a household name brand to me, but for listeners who aren't familiar with it, what does Splunk do?
Well, classically, Splunk has been in the business of kind of aggregating log data and enabling searches on log data. And more recently, Splunk is getting involved in kind of the larger observability space. And observability is kind of it's more than just logs. It's logs and it's traces and it's metrics. And because of that, we are very interested in the OpenTelemetry project in particular. We see as the future of what will be used from a library and data collection perspective for general software and hardware telemetry.
And do you want to do a, opinions are my own kind of situation? Where do we stand with you and Splunk?
Yeah, so I work for Splunk. They pay the bills, but anything I say here is really my opinions. I'm not speaking on Splunk's behalf in any way, shape, or form. And in fact, I really want to mostly focus on, talking about the OpenTelemetry project as a whole and kind of talk about its multi-vendor outlook on the world. So Splunk is just one of many, many players in that business.
Well, let's start there. What is OpenTelemetry?
Before we talk about OpenTelemetry, I want to step back a few years and talk a little bit about kind of the projects that predated OpenTelemetry. There's two major tracing projects, one called OpenTracing and another called OpenCensus that was primarily the open sourcing of a Google project called Census. OpenCensus included both distributed tracing and metrics collection, and OpenTracing was really just distributed tracing data collection. And before I got involved with the project, these two groups, the OpenCensus team and the OpenTelemetry project, kind of just got together and decided it didn't make sense to try to build two standards, that they wanted to get together and work on one standard. So OpenTracing was formed probably about 3 years ago with the goal of joining the OpenTracing and OpenCensus projects, deprecating those two projects, and then moving forward building what we think is going to be the industry standard for software and hardware data collection.
In that data collection, what is offered? Is it schema or protocol? What is the essence of the project?
It's actually a lot of pieces. It might be easier to talk first about what it isn't. And the big thing that it isn't is the OpenTelemetry project is not concerned with the visualization or analysis of any of the data that's being collected. So the goal of the OpenTelemetry project is really to build and define a standard both for the wire format for software and hardware telemetry and provide language, like programming language specific libraries to collect data and transform it into that open standard format, wire format. And then thirdly, provide a specification for what we call the semantic conventions. So when you're describing a piece of like a user interaction or some request that comes into a server, that we have a very standard way of describing that data semantically. For example, if you're instrumenting an HTTP server, HTTP is a protocol with very well-defined verbs, and we have ways where we are defining what we think the standard attributes that should be collected on an HTTP server request, and then how that data should be transformed into wire formats. So there's one final piece of the OpenTelemetry project, one of the goals, and that is what we call the OpenTelemetry collector, which is a piece of software that will collect telemetry data from essentially any source that someone could write an ingest format for, and then be able to arbitrarily transform that data and then export that data in wherever it needs to go.
So then in terms of deployment, do I deploy an instance or a fleet of those and interact with them, or what's the typical setup?
There's lots of different models for how you might deploy OpenTelemetry. The very simplest possible model you might deploy is, let's say you're a Java programmer and you want to collect data about the runtime environment that your application is running in, and kind of the requests that are coming in or whatever is going on inside your software. And you don't want to pay a vendor for a back-end analysis piece of software. You could configure the OpenTelemetry Java SDK to report that data to one of the open source analysis tools such as Jaeger or Zipkin or Prometheus, being the metrics, kind of the open source metrics backend. And you could just report the data to a local copy of those data visualization tools. The next step up, if you have a vendor, an observability vendor that you work with, for example, Lightstep or Splunk, or Microsoft has, I think in Azure, has their own observability platform. And, there's any number, Dynatrace, et cetera, et cetera. I could go, there's very many observability vendors. But if you are already a customer of one of those vendors, you can redirect your telemetry towards those vendors' ingest endpoints and then do your analysis with those, using the vendor's tools. And then if you need to scale up and you just don't have just a single instance, you have lots of, like a fleet of servers running, a fleet of containers, for example, running in AWS or wherever they might be, then it might make sense to actually deploy the OpenTelemetry collector as a common place to aggregate all of that data and send it to whatever backend you want to send it to, kind of in one centrally managed place.
Well, I imagine it's the open in OpenTelemetry that makes it possible for these variety of vendors to all offer solutions that extend on top of this. Can you talk a little bit about how that came into being?
Yeah, so when the OpenTelemetry project, when it was conceived, as I said, it came from OpenCensus and OpenTracing originally, and there were a number of vendors already involved in both of those projects. So Google primarily in OpenCensus, but there were other people who were using OpenCensus who could ingest OpenCensus data. And OpenTracing was also, there was fairly strong involvement from some of the vendors, Lightstep and New Relic and Splunk, and I'm sure a few others that I can't think of off the top of my head. But the vendors basically all really decided they were going to work together to define this open standard. And one of the big reasons why all of the vendors agreed, not only the vendors, but also the cloud providers, so Microsoft and Amazon and Google are all very heavily involved in the project, is we really think it's important for all of the vendors, and the cloud providers really feel that it's important for all of our customers to be able to instrument their code in one way and then have a choice of where they want to send that data. So if there's a common standard for all of this data collection, then it makes it really easy for people to publish libraries, software libraries that are already pre-instrumented with OpenTelemetry. And then if you're a New Relic customer or a Splunk customer or just a Google Cloud customer, you don't have to do anything special. The data is already going to be produced in the same format using the same standards that the OpenTelemetry project has defined. So we really feel that the benefit to users is not the specific details of the way the telemetry is collected, but the benefit that the users have is the fact that there is just going to be one way to collect all that data. And the vendors and the cloud providers, we're happy to compete on our experience and our analysis, and not on some sort of customized instrumentation that we spend thousands of human hours writing per year. Kind of before OpenTelemetry, each one of the observability vendors would have to maintain their own code bases of instrumentation. So, for example, I'm a Java programmer mostly, so I know the Java world better than most of the rest, but every vendor would have to produce their own instrumentation for the Apache HTTP client, which means that essentially the same instrumentation is being written by 5 or 6 different teams at 5 or 6 different companies, all producing what is nominally the same kind of data, just using proprietary formats and proprietary collection tools. That's a lot of wasted effort on everybody's part. So all of the vendors really feel very strongly that they'd rather not be investing in that. They'd rather we all work together on writing that instrumentation, and then we can compete on the experience and the analysis that we deliver to the end user.
So I know the observability space is not packed, but it's a growing market, and a lot of people are trying to get their share of it. You've also got the 3 cloud platforms involved who, in some sense could one day release their own solutions to compete. Everybody's vying for similar areas. How do you all get along in the project?
Yeah, it's a fascinating question. I think the thing that, from a personal perspective, is the most interesting to me, that we all do get along, and we all continually acknowledge that we're competitors, but we all are really working to try to find something that's great for our users. And we really all have the same users. They're software engineers, they're reliability engineers, they're operators of software at big companies and small companies. We all have the same customers, and I think we all are very, very aware that those same people are the ones that we're trying to make happy. And so even though we're fiercely competitive on a day-to-day basis from a business perspective, we all really do recognize that the end user is the one who we're trying to make happy. So we work as hard as we can, and we work together even when we disagree about the technical details of something. We don't really get into kind of the politics of my company's better than your company. In fact, it's really kind of verboten to on the CNCF Slack to tear down or even mention other competitors unless you're saying something good about them. It is really interesting to me at this point in time that this kind of open standard and this open source software is something that these business competitors can collaborate on. And, for all, I would say 75 to 80% of the people involved in the project were all being paid by one of these competitors to do this in either full-time or part-time. So our companies already acknowledge that this is something that, even though it feels weird and awkward from a traditional business perspective, that it's really important to work together on.
Well, I'm wondering if you'd be willing to imagine with me some academic person who's deeply researching something like anomaly detection. They've got some novel algorithms they've come up with. Maybe they run, with a low memory footprint on real-time-ish data. So good opportunity for them to maybe plug their solution into OpenTelemetry and create something, maybe even a commercial venture out of this. How do they get started taking that core algorithmic concept and getting it integrated?
So I think the first thing that this hypothetical person would want to do is need to know what language they're writing their code in. And then once they understand that language, or they know that what language is, then going to the OpenTelemetry project for that specific language. So there's OpenTelemetry Java and Python and .NET and Go, Ruby. All of the main languages have OpenTelemetry support, and really understand what the APIs and the kinds of data that can be produced. We haven't really talked very much about the kinds of telemetry signals that OpenTelemetry is talking about, but there are 3 kinds of signals that we talk about in the OpenTelemetry, and I think in the observability world. And those are logs, traces, and metrics. So I think most, especially kind of academic people, would probably be very familiar with metrics. I mean, you're measuring numbers about whatever the software that you're writing and when the runtime, like the counts of how many requests or the counts of how many whatever it is that you're counting. Or you could produce histograms around the shape of the data distribution if you're talking about timing things. So I think most people will be familiar with what metrics are. And there's a number of open source metric libraries that have been around for a long time. So that is one of the signals that we can produce, and probably the one that I would guess would be most interesting to people in the academic space. But there are 2 other signals that are not necessarily newer. One of them is logs, and that's not new at all. Logs have been around since the very beginning, really well before computers existed. People were writing logs on ships crossing the ocean. They're really just a point-in-time piece of data that describes something that happened. So OpenTelemetry is also working on defining a kind of a standard wire format for logs. Again, that maybe not something that's super interesting to an academic. But the final one is actually, a relatively new telemetry signal in the programming world, which is distributed tracing. And distributed tracing, essentially, if you have a collection of services, which could include databases and load balancers and actual business services, when a user request comes in, let's say you have a shopping cart application running on the web. A user goes and clicks on a button in your shopping cart. That will produce a number of different requests in those backend services. Like it might make an authorization request, and then that authorization request will talk to a database to confirm the user's password, etc. Then after the authorization happened, then there may be a request to some sort of backend shopping cart service, etc. And in order to understand the actual, like that user's actual interaction and how long things took and where there might be bottlenecks in the actual software, distributed trace essentially creates a tree of what we call them spans in OpenTelemetry, which is essentially a timed operation with a name and a set of attributes associated with it. And in order to get the kind of the distributed trace, each of those spans may have a parent. So the result of that is kind of a tree structure of timings that can describe a fairly complex interaction, especially in the ever-growing microservices architecture. So the thing that someone would want to do as an academic or any practitioner who's interested in kind of generating the standard shapes of telemetry is to decide which of those three signals their data is best modeled with, or which combination of those three signals. So there are point-in-time events, which can be logs, and there are these spans, which really do a good job describing detailed information about timings that in a distributed system. And then there's metrics, which is just everything, all the numbers you want to record. And once you've figured out kind of how your data and the information you want to collect fits into those kind of three general shapes of data, then is the time to kind of dig into the APIs and understand exactly how to generate the information that is going to be useful to you.
Makes sense. Yeah, so I would imagine metrics might be a place that I would come if I had some specialized solution. It seems like those could be rather custom. Are there any boundaries, guardrails, or best practices for what I can stuff in the metrics component of my logging?
So the metrics API for OpenTelemetry has only in the past month been stabilized, and that is we're defining a specification for what the kinds of data or how we'll be recording data for metrics. And I'm probably going to not remember everything off the top of my head, but there are probably 4 or 5 different kind of what we call metric instruments. One of those is a counter, which basically lets you count things, right? It makes sense as a counter. And you can increment singly or increment by any given amount you want. But a counter can't have negative values recorded, so it's monotonically increasing only. But we do have an instrument called the up-down counter, which does let you decrement as well as increment. And you might ask the question, why do you need both a counter and an up-down counter? And the reason is that telemetry backends often treat that data differently. If data is monotonically increasing, you can apply much simpler algorithms to the analysis than if it can both rise and fall. So those are kind of the two simplest instruments, are the counter and the up-down counter. There's an instrument called a histogram, which is, I think, a little bit of a strange name for an instrument. It's kind of what I usually think of as an output of an instrument, as a distribution of numbers. But after probably spending 6 to 9 months of bike shedding on the name of what this thing should be, we finally decided that histogram is going to be the easiest thing for people to kind of not argue about too much. I mean, I think it's the name that's used in several other common metrics libraries. I think it might be what Prometheus uses, and I think there's the Drop Wizard metrics library also calls it this. And it's essentially a way to record values. In fact, an early version of the OpenTelemetry API specification actually called this instrument a value recorder. And then it was too generic and nobody really understood what it was because it felt like it was an anything instrument. But the histogram instrument is basically you record values. And by default, those values will be recorded into some sort of histogram, usually a fixed width bucketed histogram, but we're also working on defining a standard exponential histogram as well. But the histogram instrument is the one you would use if you really need to collect distribution data about the recordings that you were interested in. And then we have 2 other instruments which really have a very specialized use case, which is you want to record things that some other process has already recorded and you just want to report them. So for instance, if you're running the Java virtual machine, it collects information about the current amount of memory that's being used. And so if you want to observe those numbers and you want to report them to some sort of telemetry metrics backend, we provide what we call several observable instruments, which essentially are just there to do this kind of callback style. We're going to periodically query this data and report data that's already been aggregated by something else. So we have a kind of this observable counter, and there's an observable up-down counter, I think, to go along with it. And then I think we have one other one, which I think we call the gauge, which is just a point-in-time number that you record. So these are kind of the instruments that the OpenTelemetry provides, the counters and the histogram and these background collection gauges and observable instruments. So the idea would be, depending on how your data is being collected and what that shape of it is, you would choose one or more of those instruments to record it. And then once you've kind of instrumented what you're interested in actually seeing, and that data is all being written to the OpenTelemetry APIs, then you would configure what we call an SDK, which actually takes that API, those API recordings, and does something with them. Standard SDKs will record that data and then deliver it to some sort of exporter to send it to a system downstream.
When it comes to something like the histograms and these counters, am I correct in assuming that new greenfield install of OpenTelemetry is going to require someone to go and kind of handcraft those and configure it, or is there anything automagical that can do that for me?
So for some languages, like Java and Python, I think it's somewhat in JavaScript and in .NET. The OpenTelemetry project also is building what we call auto-instrumentation libraries. And these auto-instrumentation libraries use all sorts of fairly arcane and complex techniques to kind of automatically inspect the code at runtime and collect this data for you. So for example, in Java, there are well-known techniques for introspecting the bytecode that is executing in a running system, and in adding instrumentation, add additional bytecode to that to actually record the metrics and traces and logs automatically without the user having to do anything. And then we provide some standard ways to configure the kind of the auto instrumentation SDK using environment variables and things like that to kind of set up where the parameters you want to apply to your running project and where you want to send that data, for example.
So that metrics API you gave us the overview on, you'd mentioned it's a recent launch or recent stabilized API, I guess. Can you talk a little bit about the process to arrive at that? I know it's a collaborative situation. How do these decisions get made?
Yeah, so that's a fantastic question, and actually kind of gets at the heart of the way OpenTelemetry works as a project. So OpenTelemetry is organized into a fairly large set of what we call special interest groups. On top of the project, there's the governance committee, which is kind of does the organizational control of the project. Like if we need new Zoom meetings set up, they do that kind of stuff. Or if there's a problem where someone's violating code of conduct, they can step in. And then there's the technical committee, which is really a group of people who are the technical experts in this observability field. And they are kind of in control of what we call the OpenTelemetry specification. There's a special interest group specifically for the specification that meets twice a week to talk about the specification, to talk about these details. And over the past 2 years, there's been a sub special interest group, or a SIG as we call it, a sub-SIG of the specification called Just to Work on Metrics. And they have been meeting twice a week for about 1.5 years to really try to hammer out exactly what the common set of metric instruments and the shape of the data we're going to be producing. But it's all of these meetings are completely open. Anyone can join into them who wants to be involved in the project. They're all on a public calendar on the CNCF website. That's the Cloud Native Compute Foundation, which OpenTelemetry is a part of. But essentially, if there's a particular topic you're interested in, you find the special interest group that you're interested in joining and participating in, and you show up at the meeting and you start participating and you start asking questions, or you volunteer to write specification, or you volunteer to help implement something. But the process is really quite ad hoc. We keep open Google Docs with meeting notes for every meeting where decisions are made, or action items, the usual kind of things you do in a corporate meeting, except that it's not corporate. It's just people who are interested in the project or in that particular group's work. So the metrics group kind of put together very preliminary API definition probably about 1.5 years ago, memory serves. And then language, they were asked for participants in the metrics group who also had language interest and expertise to go and prototype these APIs and the backend and like the SDK implementation of those APIs in their specific language, and then report back like where are their problems, where are the things that work well. Like we released alpha versions of the software for users to try out and give us feedback. Many of us who work for observability vendors use this stuff ourselves and had our teammates within our companies use these alpha versions to get feedback early. And what actually actually ended up happening when we started working on metrics in particular is the big kind of the elephant in the room when it comes to open source metrics, the Prometheus group, which I think has recently been at least somewhat rebranded into Open Metrics. They took notice and they joined the metrics special interest group with several of the people there, and they, having done metrics instrumentation and aggregation for many years, had a lot of opinions about what we were doing wrong or what we could do differently. And so at that point we kind of took a step back and worked with the Open Metrics group to kind of talk through a bunch of these issues and kind of tweak some of the ideas. We also talked to metrics practitioners from the Java community, Micrometer being a big metrics library for Java. And we got their feedback on some of the naming and some of the things. And like I said, we originally called the histogram a value recorder, and then we got feedback from the community that nobody understood what this thing was. And so we decided to do renaming based on that feedback. So now, after a couple years of deliberation and prototypes and feedback and tweaking things and more feedback, and et cetera, we think we've come to a point where the metrics specification and the API specification has been stabilized just in the past month. And now all of the language groups are going to take those API definitions and implement them. And meanwhile, the metrics group within the specification group is working hard on kind of specifying what the standard implementation, what we call the SDK, will actually look like and how it will behave. So hopefully that specification will then be solidifying and stabilizing in the next month or so, at which point all of the languages will essentially be able to go and implement that SDK specification. Of course, meanwhile, all of those languages are also prototyping all of that, and we have working implementations on what we think the final version might end up looking like. But based on feedback, again, from users and from practitioners, we'll make adjustments and we'll tweak it as we go.
So if I instrument my app with OpenTelemetry and I set up my own collector, my metrics are getting pushed there. Is the collector then a system of record, or is it a pass-through to what I choose to be my ultimate persistence layer?
Yeah, it's 100% a pass-through. The purpose of the collector really is to be that kind of universal hub that understands all the formats that could be being sent to it and can transform them to any format that you want to send the data to in the end. It doesn't do any storage of any data at all. Anything that it has is purely in memory before it gets then shipped off to whatever external system you want to be the system of record.
And what are some of the typical choices about where people ultimately persist?
Well, if people who are really open source first, open source only, they're probably going to be, for metrics, they're going to be running Prometheus or StatsD or Grafana, the open source version of Grafana. They're going to be running all of those kind of metrics backends themselves, and they'll send that data. So there are open source options for people who don't want to pay somebody and want to run their own infrastructure and they want to run their own systems. If you are a customer of one of the cloud vendors, you're running your software in AWS or Azure or Google Cloud Platform, they provide backends for all of that data. So you point your collectors. Many of them actually will run collectors for you. I think Amazon has a collector that they will run for their customers. And that data will go to the cloud vendor, and then the cloud vendor will have visualization tools, et cetera, for that. And then finally, there's the observability vendors like Splunk and New Relic and Lightstep and Dynatrace, et cetera. And if you're a customer of one of those vendors, or they'll be happy to make you a customer if you're not, and pay them money to store and visualize that data, then you can send your data to one of those vendors.
So observability is a natural and kind of obvious use case that we've been over a little bit. I see a lot of potential for other things here as well. You know, these metrics could be aggregated. It wouldn't surprise me to learn that there's a machine learning engineer somewhere doing like predictive system maintenance or something like that from IoT devices. Have you gotten the opportunity to see any of the unconventional or interesting ways people are using the service?
So I don't have a lot of insight into how machine learning practitioners might be using this data. I mean, this is really what OpenTelemetry is data collection, right? We're not doing any analysis. So certainly this is a signal that could feed into any machine learning system that you might be interested in, especially time series systems, right? Because what we're generating is time series. But one kind of maybe atypical, non-standard use that I have seen outside the data science case is people instrumenting their continuous delivery pipelines. So kind of in modern software engineering, you write your code, you check it into your source control, something automatically picks that up, builds the code, deploys it to some sort of test environment, automated tests runs, and then once that's done, it gets deployed into your staging environment where some more automated tests will run, and then once those have all passed, then it'll be deployed into your production environment. Well, this is a fairly complex set of operations that also is very important to make sure you understand where it is or isn't breaking down. So this is a case where it's not kind of your observability of your end systems, but observability of your pipelines and infrastructure that build your systems as well. So this is one case that I have seen people getting more interested in. I've seen, like in Java at least, the Maven and the Gradle build systems. People are instrumenting those. I did a side project where I did some Gradle instrumentation myself, and then you plug that into your CI/CD build pipelines and have that data then emitted and visible so you can see what's going on, not only in your running software, but in your build. So where is the time being taken in your build? Maybe is there some place where you could optimize it? Or is there some way you could kind of combine build steps and to make it better or something like that? So this is maybe a non-standard but growing area of where instrumentation is being used, and telemetry data is being very useful.
And what's the future of OpenTelemetry? It's a work in progress, but also stable to a certain point. Where do you see things evolving down the road?
So where we are right now is the tracing specification is stable. The tracing implementations have been out now for a while in most of the major languages. As I said, metrics is really in the process of becoming stable in the next few months, with the API being stabilized and the SDK specification coming very soon. The next thing after that is logs. Logs are super important, kind of the oldest of the telemetry sources really, and the OpenTelemetry is defining a standard wire format for log data. And it's unclear exactly what the shape of the logging API is, because every language probably already has a logging API and we don't want to reinvent that wheel if we don't need to. But over the next year, we're almost certainly going to be stabilizing the logging APIs and SDKs. So once we've got those three things done and stable, then we're done, right? No more work. Obviously not, right? I think there's actually a new group it's two groups, one of which I am actually actively involved with, is what we call client telemetry, or often referred to in the industry as real user monitoring. So this is measuring the performance of actual users using applications and being able to detect like if your mobile app is crashing a lot, being able to detect that and then understand why and fix those bugs. So that group, which we call client telemetry, and a new network monitoring group based on the eBPF, which I don't know anything about network monitoring, so I'm probably going to say things that aren't correct. But there's a network monitoring group also that is really getting ramped up in OpenTelemetry. And the two groups, the client telemetry and network, have really identified a new signal, which we're preliminarily calling an event. So it's something like a log, but it's a little bit different. And so this event API, maybe we're not exactly sure what it means, but over the next year, we're going to try to understand what an event is. It's a point in time thing with data associated with it. So it's, fits into these ideas, but it is shaped slightly differently than logs probably, and doesn't really look like a span and a trace. So I think the next step after logs is really to come to a common understanding of what this event API might be. So we can collect both for client telemetry and network telemetry, and we think probably for IoT use cases as well, understand this event. Like an example of an event in the mobile space, for example, is your network might change from being Wi-Fi to being 5G, like if you're walking down the street. And so recording that event is very interesting, because if the performance of the application then becomes radically different on those two different networks, it's very interesting to know that, there was a point in time when something changed, and then be able to reason about maybe there's a causal relationship between the performance characteristics of the app and the fact that this change in the network occurred. So that this event API or this event data model, whatever it ends up being, we're really still trying to figure it out. That's what's coming next, I think, after metrics and logs are complete.
That's interesting. It seems like a natural and, dare I say, obvious thing to add, but yet when you think about all of the variety of situations one might want to apply that, the standard feels, to me, a little bit intimidating. How do we do something that's pleasing universally? Maybe to wrap up, do you have any guiding thoughts on how you'll approach that?
Well, I think the way that we often tend to approach this is to really think about so if we have a new signal, for example, this event signal, think about the superset of all of the shapes of the data that might take. And by shape of the data, I mean we're going to be recording something about that event that happened, like probably some sort of name, and then some sort of attributes. But are those attributes simple strings, or are they numbers? Are they more complex data structures? And so try to find the superset of all of the use cases that we know about for these events. So looking at network, looking at IoT, looking at mobile and web browsers, and find the superset data model. So that's kind of step one, is to kind of define that data model. And from the data model, we'll actually define probably the wire format at that point. So that's kind of step one. And then this is very speculative, but I think most people are thinking right now that the data model for events is probably going to look exactly like logs. And so we probably will use the log data model for events because the log data model is very, very flexible. But once we've got that data model settled, then we need to start thinking about how are people who are writing code, people who are writing applications, people who are building telemetry into their IoT devices. Like, how do we make an API that's going to be really easy and obvious for them to use and record that data? And I suspect at this point, this event API will bifurcate, and we may have one that's very specific for mobile devices, and one that's very specific for IoT devices, and one that's specific for network devices. But the next step then is to define those APIs, and maybe there will be a common API for events, but maybe we'll bifurcate the API into kind of implementation or use case specific APIs. But that'll be the general process that we go through.
Well, John, what's the best place for people to follow the project online?
Yeah, the first place to go is OpenTelemetry.io, which is the website where there's a ton of documentation and lots of words and pretty pictures and some cartoons, I think. And then if you're a software engineer, all of our code is up on GitHub. All of the meetings that are run as a part of the project are all public. The public calendars are all linked to from the OpenTelemetry.io website, I believe. If not, they're certainly in the community repository in GitHub under OpenTelemetry. But if you want to get involved, find the thing you're interested in and join in a meeting. Come to a meeting. We love newcomers. We'd love to have new people and new points of view in the project because the more points of view we get, the more general and useful solution we're going to end up with.
And what's the best place for people to follow you yourself online?
So on Twitter, I'm JK Watson. On GitHub, I'm JK Watson.
Well, you've got an impressive green set of tiles on your GitHub, I have to say.
Yeah, I write a lot of code. It's what I love.
John, thank you so much for taking the time to come on the show.
Well, thank you very much. It's been a pleasure being here.
That concludes another installment of Data Skeptic Time Series. Our guest today, John Watson. Myself, Claudia Armbruster, as associate producer, Vanessa Bly, guest coordinator, and our host, Kyle Polich.